Welcome to Cookie's Maths and Science Hub. In this video, we'll be exploring the equations of motion and how to apply them to some simple problems. There are three standard equations of motion and they are shown below. That is, final velocity equals initial velocity plus acceleration multiplied by time. Then we have final velocity squared equals initial velocity squared plus 2 multiplied by the acceleration multiplied by the displacement. And finally, we have the displacement is equal to the initial velocity multiplied by time plus half multiplied by the acceleration multiplied by the time squared. Now, all it is, at the end of the day, with any sort of these equations, is substituting in our known values and then solving for our unknown values. So it's quite important that you get used to what each letter represents. Although you'll normally find this on most formula sheets that you're allowed to take into examinations and tests. So our S is our displacement, our U is our initial velocity, our V is our final velocity, our acceleration is A, and our T is time. It's a good thing to note that S, U, V, A, so displacement, velocities, and acceleration, are all vectors. Now remember from our scalar and vector video, that means they require direction, unless otherwise stated in the question, or no direction is present. Okay, let's get into an example now. If the initial velocity of an object is 5 meters per second, and the object accelerates at 4 meters per second squared over 8 seconds, what is the final velocity? The easiest way, and I cannot stress this enough, to do any of these questions is to simply write out what you have and then figure out which formula you're going to use based on that. So I've got my three formulas on the right-hand side here, so we can use that to help us out. So the thing we're looking for in this case is our final velocity. So our V is just going to equal unknown, question mark, you might say X, depends on what you like to write. U equals 5 meters per second, because that's our initial velocity. A, which is our acceleration, is 4 meters per second squared, and T equals 8 seconds, which is our time. So we're looking for our V, and we have our U, our A, and our T. Hopefully you can see we're just going to use this first formula on the top here on the right, because that has everything we need to solve for V. It has one unknown. That's the key. You're looking for just one unknown. So therefore, V equals U plus AT, which gives us V is equal to 5 plus 4 times 8, which is going to give us V is equal to 37 meters per second. And although direction isn't provided in the question, it doesn't state that we shouldn't include direction. So in this case, you should always just write in the direction of motion, as we don't know what direction that is, but we're still indicating that that should have a direction. Looking at another example now, we have, given that the final velocity of an object is 9.21 meters per second, and the object travels 10 meters east as it accelerates for 3 meters per second squared, what is the final velocity? Okay, once again, it's best if you just write out the stuff you know, and then look for the equation that fits. So in this case, we know that our final velocity, or our V, is going to equal 9.21 meters per second. However, we don't know what our U is, so let's just say U equals question mark. Again, you could use a variable if you prefer. A is just going to then equal 3 meters per second squared, as we're told it accelerates for this much. And S, which is our displacement, is going to equal 10 meters east. We need to be careful there because it does say east. We need to make sure that we keep that in mind for our final answer. So hopefully by looking at that, you can say we've got S, A, and V, and we're trying to find U. So we're going to use the second formula in this case. That is V squared equals U squared plus 2AS. So plugging in our numbers, we get this. 9.21 squared equals U squared plus 2 multiplied by 3 multiplied by 10. Now, I want to clarify two different ways you can do it from here, or even before this step actually. Some people like to rearrange before they plug their numbers in. So you would rearrange the equation for U squared, or just U, before you plugged your numbers in. This can save some time, and some people prefer to do it this way. However, if you're not so confident in your algebra skills, then I suggest you just plug your numbers in first, as I find that is a bit easier way of doing it. However, the other way will still get you the same answer if you've done it correctly. Regardless, we then have U squared equals 84.82 subtract 60. That is simply from squaring the 9.21 and then taking across that 2AS, or that 2 multiplied by 3 multiplied by 10 to the left-hand side. Remember, to get rid of an addition, we have to subtract, and whatever we do to the right, we have to do to the left. That'll give us u is equal to the square root of 24.82. Remembering, to get rid of a squared, we take the square root of both sides, which gives us u is equal to 4.98 meters per second east. Remembering, it's now east because the direction is given in the question for our displacement. Okay, let's look at a final example now. Find the final velocity of an object traveling for 2 seconds, accelerating at 4.5 meters per second squared, but travels 18 meters north. Okay, let's write out what we have. So we know that our final velocity is what we're looking for. So that's going to be unknowns. We're going to equal question mark or x, or like I said, any variable. We also don't know our initial velocity. So we'll put that down for now as something we don't know. Acceleration equals 4.5 meters per second squared from the question. Our displacement is 18 meters north from the question. And we know it travels for 2 seconds. Now, as we're trying to find v, you'll see the only two equations that solve for v also require that we have u, but we don't have u. What this means is, this is a two-step question. Effectively, we're going to have to find what u equals, then use that to solve for v. So, if we ignore the v for now, and we look at u, which is what we're trying to find to start with, and we have AST, you can see that we're actually going to use our third equation, which is S equals UT plus half AT squared. Now, as I discussed previously in the last example, you can actually rearrange the formula prior to substituting the numbers in. So if we want to get u by itself, we'd have to subtract that whole right-hand side from S to get it over to the left-hand side, and then divide all of that by t. And I've written that out here. As you can see, it looks a bit more messy than just putting the numbers in, but if that's the way you prefer to do it, you will still get the right answer. So then all I have to do in this stage is then substitute my numbers in. No more rearrangements. So u is going to equal 18, which is our displacement. Subtract half multiplied by 4.5 multiplied by 2 squared. The 4.5 being our acceleration and the 2 being our time, having to square it in this equation. All divided by our time, which is 2. Plugging all that into your calculator, you'll get u is equal to 4.5 meters per second. Now that we have u, we can look back at our equations and we can see that we have u, a, and t. So we can simply use v equals u plus at to find our v. So v is then going to equal 4.5 plus 4.5 multiplied by 2, which is just going to give us 13.5 meters per second north. Don't forget the north. You will lose marks if you miss your directions. It's always important to write them out as well. Thanks for watching. Hopefully now you have a good understanding of what the equations of motion are and how to use them to solve for unknowns in a variety of problems. Be sure to leave a like on the video and subscribe to our channel for all future maths and science needs. Hope to see you again soon.